Welcome back, Focus Learners. Today, we're jumping right into a topic that's literally reshaping how we study, work, and interact with information. We hear the term artificial intelligence tossed around all the time, right? But in this explainer, we're going to look at the scholastic evolution of AI. Basically, we're looking at how artificial intelligence actually grew up. Think about it. Just like a student advancing from kindergarten all the way to college, AI has gone through its own, honestly fascinating educational journey to become the super powerful tool that's sitting on your desk today.
Okay, let's dive into this. When you open your laptop to do research, or maybe you use a smart study aid to check your grammar, you're interacting with the result of decades of technological education. But what exactly is artificial intelligence? And more importantly, how did it learn to get so incredibly smart? I want you to take a quick second here. Consider what AI actually means in your daily scholastic life. Is it just a really fast search engine, a fancy calculator, or is it something much closer to an evolving digital brain? Well, to figure that out, we need to establish exactly what we're dealing with.
So, artificial intelligence. We're defining it here as the historical development of computer systems designed to evolve, solve problems, and learn similarly to human intelligence. Notice those key action words, guys: evolve, solve, and learn. AI isn't just about a machine holding some static encyclopedic database of facts. No, it's about a dynamic system that actually mimics human cognition. Setting this baseline is absolutely crucial before we jump into our timeline, because it frames everything we're about to see. We are literally tracking the history of a machine's ability to think.
All right, here's our lesson plan for today's explainer. First, we'll explore the dawn of AI. Second, we'll track the evolution of machine learning. And finally, number 3, we'll look at AI in the classroom. 3 simple steps to help us mentally map out what is an incredibly complex journey.
Section 1. The Dawn of AI. We are tracing the earliest concepts of thinking machines.
Let's travel back in time a bit. I want you to treat the early days of AI just like a brand new student stepping into a classroom for the very first time. You know, before you can write a brilliant essay, you gotta learn the basic ABCs. And for early computer scientists, teaching those ABCs to a machine was an astronomical challenge. In the 1950s, we have the dreamers, like the folks at the famous 1956 Dartmouth workshop who first coined the term artificial intelligence. They envisioned machines that could theoretically think. Jumping to the 1980s, we see the first explicit, rigid programs. This is kind of like a student learning to strictly follow the rules. By the 2000s, boom, there's a massive shift with the rise of machine learning. And this brilliantly illustrates the steady growth of computing power, utilizing early neural networks, and this massive explosion of internet data. And finally, the 2020s, bringing us to the modern AI we see actively participating in the classroom today.
But wait, let's pause on those early days for a sec. Imagine, if you will, trying to complete your most complex, demanding homework assignment. Maybe you're calculating orbital mechanics or writing a massive comprehensive history paper, but you have to do it using a brain the size of a simple, solar-powered pocket calculator. Honestly, no way, right? Well, that is exactly what early computer scientists were up against. They had brilliant, world-changing ideas for solving major problems, but they were totally boxed in by massive computational limitations. The hardware simply couldn't keep up with the software of their minds.
Now, what's really interesting about this slide is how these specific historical hurdles actually define the future of technology. Overcoming these obstacles laid the absolute groundwork for everything we use today. First off, scientists had to invent better hardware just to overcome those massive computational limitations. Then, they had to figure out how to teach computers basic, rigid rules. And perhaps the most difficult hurdle of the whole shebang, translating flexible, nuanced human logic into simple, binary machine code. I mean, how do you teach a machine that only understands ones and zeros what an idea even is?
Moving right on. Section 2. Evolution of machine learning. Let's see how machines graduated to complex problem solving.
So, eventually, those early hurdles were cleared. Computing power finally caught up. And just like a student moving from middle school memorization right into college-level critical thinking, the technology graduated. We entered a new historical era where AI didn't just follow instructions, it actually learned how to learn. So the crucial point is the stark contrast between these two eras. Early AI required explicit step-by-step programming by humans to solve problems. It was completely spoon-fed. If you didn't write the exact code for it, the machine couldn't do it. But evolved AI, thanks to breakthroughs in artificial neural networks, it learns independently by studying massive amounts of historical data. It's literally the difference between telling someone exactly how to ride a bike by explaining gravity, momentum, and pedal angles versus just letting them practice riding the bike thousands of times until they naturally figure out the balance themselves.
Here is that independent learning process broken down into 4 distinct steps. 1. Ingest massive amounts of data. 2. Identify hidden patterns and rules within that data. 3. Practice problem solving. And 4. Output complex learned responses. Think of this technological process like a super dedicated student locking themselves in a giant library. To prepare for a major exam, they don't just read one book, right? They read the entire library. They ingest the data, they notice the overarching themes and patterns, they practice the equations, and finally, they can synthesize entirely new, complex essays on the final test.
Okay, let's move to Section 3 and see how this builds into AI in the classroom, connecting AI's evolution directly to your scholastic life today.
We've traced the timeline from the conceptual 1950s, past the rigid coding of the 80s, and straight through the data-rich machine learning revolution. Now, let's bring that historical evolution right into your daily world. Because the history of AI isn't just about computers, it's about evolving tools that actively change how students learn and solve problems today. Let me break the fourth wall for a second here and ask you directly. How does understanding this technological evolution change the way you look at your own scholastic goals? When you realize the AI assisting you isn't just some magic box, but the result of decades of digital schooling, does it change how you leverage it? Well, it absolutely should.
Because that long, arduous journey from those early programming attempts in the mid-20th century has finally placed these incredibly powerful, evolved tools right on your desk. The modern classroom AI acts as an evolving smart tutor tailored specifically to your pace. It helps organize massive amounts of study data so you don't just drown in information. It actually challenges students with critical thinking rather than just handing out easy answers. What you are using right now represents the absolute current peak of machine evolution. It's literally a historical marvel functioning as your personal study buddy.
Which brings us to our final thought. We've seen how AI grew up. We've seen its curriculum from the 1950s to today. But education never truly stops, does it? So if AI continues to evolve and learn alongside us, how will you shape its role in the classrooms of the future? Is it going to be a crutch, or will it be a catalyst for your own human brilliance? Think about that as you close this explainer and head back to your own studies. Stay focused, stay curious, and keep learning.